Hey everyone, and welcome to this explainer. Look, if you're an undergrad diving into discrete math or logic right now, you've probably slammed headfirst into set theory. And honestly, it can feel like you're trying to learn a completely alien language, right? Well, stick with me today, because I'm going to give you a super clear, straightforward path to mastering two foundational but famously tricky math concepts. We're talking about the identity law and the idempotent law. By the end of this, you're going to see exactly how these laws govern the behavior of sets, and it's going to give you a massive confidence boost for your next exam. But before we even touch the definitions, I want you to chew on this question for a second. Why does combining a set with itself just give you the exact same set? Think about it. In standard everyday math, if you combine a number with itself, like 1 plus 1, you get something totally new. You get 2. But set theory? It operates under a completely different logical framework. Today, we're essentially going to completely challenge your baseline intuition about how mathematical operations work, and we'll rebuild it from the ground up. So, here's our survival guide game plan for today. We'll start with a quick introduction to set laws, then we'll demystify the identity law and unpack the idempotent law. After that, we're going to put those two head-to-head, and finally, we'll wrap up the whole shebang with some really practical exam tips and tricks. Let's get into it.
Starting off with Section 1, Introduction to Set Laws, Mastering the Basics.
Okay, so the absolute secret to mastering set theory is deeply understanding its most basic building blocks. Seriously, if you understand these core rules, specifically how unions and intersections interact with the empty set and the universal set, it basically clarifies the behavior of absolutely everything else in set theory. You can kind of think of these as the fundamental laws of physics, but for sets. If you know how the empty set, which literally contains nothing, and the universal set, which contains absolutely everything, if you know how they behave, you can solve even the most mind-bending problems.
Moving right along to Section 2, Identity Law, Demystifying the Concept.
All right, let's dive into this. The identity law, or the rule of identity, basically says that operating on a set with a specific identity element, like the empty set or the universal set, leaves your original set completely unchanged. Now, the absolute key phrase here is identity element. In the math world, an identity element is just this special type of value that, when you apply it in an operation, leaves the other value exactly as it was. It respects the original identity of your set. Okay, let's look at these 4 core formulas. We've got 4 primary scenarios to tackle here. First up, the union of set A with the empty set equals A. Second, the intersection of set A with the universal set equals A. Now take a look at the next two, because these show the inverse interactions. The union of set A with the universal set equals the universal set. And finally, the intersection of set A with the empty set equals the empty set. Let's actually break down the logic of why this happens, because it's pretty cool.
If you ever find yourself getting tripped up by that first formula, the union with an empty set, just remember this plain English translation. Nothing added, so the result is the same. I mean, since the empty set literally has 0 elements inside it, making a union, which is just combining sets together, is exactly like pouring an empty glass of water into a full glass. You literally haven't added anything new, right? So your original set stays exactly as it was.
Let's make this crystal clear with a concrete example. Just imagine set A contains the numbers 1, 2, and 3. If we do a union with the empty set, the result is still just 1, 2, 3. No new elements were introduced at all. Now check out that second scenario, set A intersecting with U, the universal set. The universal set contains every possible element in whatever problem you're working on. So if you ask, hey, what do my set A and the entire universe have in common, which is exactly what an intersection is asking, the answer is just the elements of set A, 1, 2, and 3. It perfectly proves that plain language logic we just talked about.
Next up, Section 3, Idempotent Law, Understanding the Law.
So, the idempotent law basically translates to the rule of self-repetition. It states that performing a union or intersection of a set with itself yields the exact same set, with absolutely no changes. I know, idempotent sounds like this incredibly heavy piece of mathematical jargon, but honestly, it basically just means repeating an operation multiple times without changing the initial result. Doing it once says the exact same effect as doing it 100 times.
Notice how surprisingly simple these formulas look, especially compared to the identity formulas we just went over. We really just have 2. The union of set A with itself equals set A, and the intersection of set A with itself equals set A. That's it. We aren't introducing any outside identity element, like the empty set or universal set here. We're strictly working with set A.
So the absolutely crucial point here is this. Repeating the exact same thing twice creates no new elements. If you take all the items in your set and combine them with those exact same items, a union, you don't magically get duplicates. Sets only care about unique elements. And if you're looking for commonalities between a set and itself, an intersection, well, naturally, every single element is shared. Makes sense, right?
Let's anchor this idempotent concept with another quick numbers example. Say set A is just the even numbers, 2, 4, and 6. If we union set A with set A, we just get 2, 4, 6. And if we intersect set A with set A, yep, we still get 2, 4, 6. Unlike standard addition, where, 2 plus 2 equals 4, in set theory, the union of a set with itself adds absolutely nothing new. The set remains exactly the same.
All right, Section 4, Identity versus Idempotent, comparing the two laws.
When we contrast the mechanics of these two directly, a really fascinating pattern emerges. In both laws, the final result is unchanged, right? You end up with your original set. But the ingredients used to get there are entirely different. The identity law uses a distinct external identity element, kind of functioning like a mathematical mirror. The Idempotent law, on the flip side, uses the exact same set twice. It's more like a mathematical echo. One relies on a special external tool, and the other relies purely on self-repetition. Fully grasping this distinction is your key to mastering set logic.
And finally, Section 5, Exam Tips and Tricks. Ace your next test.
And this brilliantly illustrates what you want your study materials to look like. When you're prepping for a big exam, you really don't want to be rereading dense, wordy paragraphs. You want quick, highly digestible study notes, just like these, that immediately trigger your understanding of the core mechanics.
To help you with that, here are some final, plain language memory hacks you can totally steal. If you see a union with the empty set, just think to yourself, nothing added. If you see an intersection with a universal set, translate that in your head to keeping your own from everything. And if you see a union or intersection with the exact same set A, just tell yourself, repeating the exact same thing. By assigning these super simple English phrases to the abstract mathematical symbols, you can intuitively solve the formulas without having to rigidly memorize some giant chart. So, I'm going to leave you with this final thought. How will mastering these two foundational rules actually speed up your problem solving on your next big test? Listen, when you stop trying to just rote memorize abstract symbols, and you start actually understanding the logical story behind the identity and idempotent laws, set theory suddenly becomes a highly intuitive tool. The next time you're staring down a massive, complicated equation full of unions and intersections, look for these simple laws hiding within it. They just might be your shortcut to the right answer. Thanks so much for joining me on this explainer today. Keep studying smart, and I'll catch you next time.